So we managed to get hold of a XRF X-Ray Fluorescence machine. This one's portable, so PXRF. There has been some background work using X-ray technology to look at total plant nutrient concentrations. We proposed to SAGIT to look at different plant crop types, develop calibrations against an ICP, acid digest ICP machine, which is a normal procedure the commercial lab goes through, which has got associated costs and time of or labour time associated with getting the end result. The theory behind XRF is it emits X-rays to a sample. So the theory is that when we shoot this sample with X-rays, elements or electrons from a certain element will get excited, go to a higher energy state, and then it drops back down to a lower energy state, and when it does that, it actually emits a signature. Depending on how much nutrient content is in that material, will give you back a proportionate signal. So we've been getting the signal, the counts, or a reading of ppm, which is inbuilt into the machine, and calibrating that against the acid digest, followed by an ICP measurement. So the theory is if we can do samples like this quite rapidly, so it can take between 30 seconds to 2 minutes to get a result. We're cutting down that time of measurement, and also the acid digestion and labour and the costs of running the ICP. So this only runs, the cost of this is only electricity after the initial purchase. So there's been background data suggesting XRF is really good on prepared samples, so as you can see, ground. So we developed for more crop types applicable to South Australian broadacre agriculture, and we found really good results with prepared samples and ICPs: phosphorus, sulphur, zinc, potassium and calcium. So that's the elements that's most applicable to broadacre agriculture or nutrients that the instrument can do. Unfortunately, it can't do nitrogen, but we're looking at those elements, primarily phosphorus. So the next step, once we had those calibration sets, was to go out in the field. We had another associated project with SAGIT looking at phosphorus responses to wheat and barley, so we were able to go tag along with those field trials and take this out in the field and actually see if we can get an accurate determination in field while the plant's growing. So we did that in the field. Unfortunately, it seems that the water content of the growing plant seemed to nullify the signal that you can get back. But once we brought that sample back to the lab, dried it, we didn't need to grind it, but placed it on the XRF, and we got really good calibrations again. In terms of cost, it's going to be quite effective in time. You can push through more samples depending on budgets, and good for researchers, I guess, as well, if they're on small budgets, because ICP does cost a bit. So, and especially for phosphorus, it's quite important to people on replacement fertiliser programs will get a determination of the grain content, of phosphorus content, and then as they know the yield off the paddock, they can get an overall removal of phosphorus from that paddock and go in the next year with that replacement rate. So if we can do this on farm as the harvest is going through and get an idea, even variability in the paddock, I think that's going to be quite a useful tool.